Hi students, welcome to Engineering Graphics class. I am Dr. Vinodkumar. In this video, we are drawing the problems belonging to the 5th module of CUSAT University question April 2019. The questions from 5th module belongs to isometric and perspective. We will draw isometric first. The question says, there is a square prism 40 mm side, 65 mm tall. A square prism 40 mm side, 65 mm tall. It then tapers to frustum of a square pyramid with the top 20 mm square through a height of 30 mm. The total height is 95 mm. You are asked to draw the isometric projection. I repeat, a square prism 40 mm side, 65 mm long stands on the ground. From the top, it tapers to frustum of a square pyramid through a height of 30 mm. The tapering is through a height of 30 mm and it ends with a square of 20 on the top. The 40 square tapers to 20 square on the top through a height of 30. So the total height is 65 plus 30, 95. What you have to do? You have to first of all draw an isometric scale. What is the length of the isometric scale? The length of the isometric scale must be 95. 95. Okay. You know how to draw an isometric scale. Draw a line of 95 mm length. Mark 20 on it. (40), 20, 40, 65, 90. 95, sorry. 65, 95. This is 15 degrees. This is 45 degrees. You know the construction of isometric scale. That is isometric scale. Now through these points, draw lines parallel to the side. You get what? You get the corresponding isometric lengths. This is ISO 20, this is ISO 40, this is ISO 50, this is ISO 50 is not required. Okay, this is not required. This is ISO 65, this is ISO 95. Okay. Then I think 30 is required. This is 30. 30. ISO 30 is required. Okay. Now, draw a horizontal line. Draw a 30 degree line. Draw a 30 degree line. Take ISO 40 on this side. Take ISO 40 on this side. Draw lines parallel to them. You get the fourth corner. From these four corners, take ISO 65 up. ISO 65. Measure ISO 65 up and then connect. ISO 40 side. ISO 40 side through a height of ISO 65. From ISO 65, measure ISO 30 up again. We could have drawn it in the same stretch, but for clarity I am changing. Again measure ISO 30. Now, this is an ISO 40 rhombus. You actually want an ISO 20 rhombus there. What you have to do? You have to subtract 40 minus 20 equals 20. Divide by 2, 10. ISO 10. Mark ISO 10 here. Mark 10 here, get its ISO length, ISO 10. Subtract ISO 10 from all four corners. Connect them, very light lines. What do you get? You get here a rhombus of ISO 20. ISO 40 minus 10 minus ISO 10, minus ISO 10. So the inside center is ISO 20. You have got a rhombus of ISO 20 side. Connect them to the respective corners. Then firm. Since I am not using instruments, some of my lines may overlap or duplicate. You have to bear with me. When you draw two dimensions, you will get perfect shape. This completes the drawing. This become dotted. This become dotted. This become dotted. The remaining are construction lines. They are also supposed to be dotted. Now you have to mark the dimensions. How do you mark the dimensions? You have to mark what is this. How much is it? It is square ISO 40. When you write square ISO 40, you need not mark on this side. Okay. Then height. How much is the height? ISO 65, ISO 30. What is this? This is square ISO 20. Instead of writing ISO 40, you can write 40 into 0.816, 65 into 0.816, 30 into 0.816, 20 into 0.816. Or you can even write 40, 65, 30, 20, etc. And then on the side you can print ISO projection. That also is permitted. But I will advise you to write either ISO 40 or 40 into 0.816 for safety. It's a reasonable question. Simple question. Only 12 points to decide. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Argument is simple. ISO projection, there is no spherical part, there is no circular part. So the drawing procedure will take less time. I hope you understand. Okay. Thank you. When we come to the second problem of the fifth module, it's from perspective projection. The solid is very similar to the solid we have drawn in isometric projection. The question says a square prism 40 mm side, 50 mm height. A square prism 40 mm side, 50 mm height, tapers from there to 20 mm square through a height of 20 mm. A square prism 40 mm side has got a height of 50 mm. Then it tapers to frustum of a square pyramid. Frustum of a square pyramid of top side 20 mm and height 20 mm. So what's the total height? 50 plus 20, 70. 40 mm into 40 mm through a height of 50. Then it starts from 40 mm into 40 mm and ends at 20 mm into 20 mm through a height of 20. So the total height is 70. It is resting on the ground. It is resting on the ground on its base, on a square face, with one side making 25 degrees to PP and a corner of that side on PP. A corner on PP and the side containing the corner making 25 degrees to PP. This corner is 40 mm to the right of the eye. So where is central plane? Central plane is 40 mm to the left of A. The corner A is 40 mm to the right of the eye. So where is the eye? Eye is 40 mm to the left of A. So 40 mm away from A, draw a central plane, and on that central plane 100 mm away, 100 mm away, locate SP. What is SP? SP is the location of the eye. SP is the location of the eye. In the question, instead of saying eye, they say edge. Instead of saying eye, they say edge. it is a typing error. It is an error. I am correcting that error in the solution. Actually, the question, you can say it is wrong or it is misleading, because instead of I, they say edge. They say the corner A is 40 mm to the right of the edge. It is totally confusing. Actually, it is 40 mm to the right of the I. Okay, let us take I. 40 mm to the right of the I. Therefore, I is 40 mm to the left of A. So, this is SP. Now, some distance below SP, draw HL. What is HL? HL is the horizon plane. And it is also said that the edge is 100 mm in front of PP and 90 mm above GP. Actually, it is I. I is 100 mm in front of PP and 90 mm above GP. So, where is GL? GL is 90 mm below HL. I repeat the whole thing once again. Draw PP. What is PP? Picture plane. Draw a square 40 mm side. Inside centrally draw a square 20 mm side, so that this angle is 25 degrees. Name it A, B, C, D, corners of the bottom, E, F, G, H, corners of the top, and corners of the topmost 20 mm side square is I, J, K, L. Agreed? Then from A, measure 40 mm to the left and draw the central plane, and on that central plane 100 mm away locate SP. Then some distance below SP, draw HL. 90 mm below HL, draw GL. That is the initial construction. Now you have to draw the perspective view. There are various ways of drawing this. One is called visual ray method. When you draw by visual ray method, what you have to do? You have to draw an elevation of the object here. Then join all points of the elevation to SP dash. If this is SP, right below on HL is SP dash. SP dash is നേരെ താഴെ HL ലാണ് SP dash. SP is നേരെ താഴെ HL ലാണ് SP dash വരിക. So SP dash is right below SP on HL. Join all points of the elevation to SP dash, and onto them drop the intercepts of all these 4 plus 4 plus 4. 8 points. Actually, I mean 8 points only, because A and the 2 points coincide. No, 4 points coincide on another 4 points. So totally 8 points. 8 intercepts you have to draw. That is one way of doing that. The other way is 2 vanishing points you can find out. What is a vanishing point? Vanishing point is drawn by drawing a line parallel to this side through SP. It cut picture plane at small v1, drop it down, you get capital V1. Capital V1 is the vanishing point of all these lines parallel, all AB and all lines parallel to AB. And also find out the vanishing point of this side, vanishing point of AD. For that you draw a line through SP parallel to AD. You get V2 here, drop it down to HL, you get capital V2. Capital V2 is the vanishing point of all these lines parallel to AD. By using those 2 vanishing points also you can draw. Then, however, in this case, the easiest method is to draw this using single vanishing point. Because when you use visual ray method, the elevation comes here. How many points are there? 4 points at the bottom, 4 points at 50 mm height, and 4 points at 70 mm height. There are 4 plus 4 plus 4, 12 points. Those 12 points are to be joined to SP dash. Therefore, there are 12 lines. Agreed? 12 lines. Onto those 12 lines, you have to draw these intercepts. Everything will become so close and can sometimes confuse you. Agreed? Now, if I go for double vanishing points, that also may sometimes create some difficulties. So many lines. When I use single vanishing point, it seems to be a little bit spacious, and the lines will not, all the lines will not mix up. Let's try that. You can follow any of the methods. Okay. When you use single vanishing point, I am going to draw it using the vanishing point of this side. To get the vanishing point of that side, what I have to do? I have to draw a line through SP. I have to draw a line through SP parallel to the side AB. it cut picture plane at V1, then drop it down to HL, I get capital V1. What is capital V1? Capital V1 is the vanishing point of AB and all lines parallel to AB. Agreed? Now, I join all points of the object to SP to get intercepts. How many intercepts you will get? How many lines you have to draw? You have to draw 8 lines. VF. CG. Before that, J. Then K. I. A you need not draw because A is already on PP. CG. L. H. 1, 2, 3, 4, 5, 6, 7, and since A is on PP, that's the 8th point. 8 intercepts you have got. 8 intercepts you have got. Now, I extend this side. I extend this side to cut picture plane. Extend this side to cut picture plane. I also extend this side to cut picture plane. I call this D1 H1. I call this I1 K1. I call this this is L1 K1. L1 K1. I call this I1 J1. Now, what are they actually? I have extended the side CD. I have extended the side CD to cut here at D1. I have extended the side KL to cut here at K1. I have extended this side IJ to cut here at I1. I1 and J1, L1 and K1, D1 and H1. Drop this down. Drop this down first. Also, A without extension, A is already on PP. That also has to be dropped down. Now, what is this? This is capital D1. Then, if this is capital D1, where is H1? H1 is 50 mm above that. H1. This height is 50. Then, where is L1? L1 is 70 mm above the ground. L1. This height is, I mark here, add up 20. L1 height level is 70, so 50 plus 20 is 70. What is this? At the same level of L1 you have got what? I1. Agreed? This is what? A. Exactly 50 mm above A you have got what? E. I am not calling this A1, E1. I have here called D1, H1. Here I am calling A because A is already on picture plane. Agreed? Now, if you connect A to B1, it will contain B. If you connect E to V1, it will contain F. If you connect D1 to V1, it will contain D as well as C. If you connect H1 to V1, it will contain H as well as G. If you connect L1 to V1, it will contain L as well as K. If you connect I1 to V1, it will contain I and J. Where are they? They are on the respective intercepts. Agreed? Let us connect them. L1, I1, H1, D1, E1, A1. All the lines are drawn. All the lines are drawn. A, E, D, H, L, I. Now you have to drop intercepts. Now we have to drop intercepts. I am going to change the color of the pen. I am dropping intercepts from the rightmost point onwards, otherwise it will overlap. And sometimes, since it is easily removed, see, if you touch it, it will get erased. So I am drawing from the rightmost point. One. I will drop all the intercepts first, then I will talk. I will drop all the intercepts first. Please bear with me if you cannot see because of my body blocking the drawing. I am trying my level best to make it visible for you. I am dropping intercepts from each point. I think all intercepts are drawn. All intercepts are drawn. What is this? This is B. I will go in an order. What is this? That is C. What is this? This is D. A, B, C, D. Okay. Then this is E. What is this? F. What is this on the intercept of G? F, G. What is this? H. A, B, C, D, E, F, G, H. Agreed? Then L. What is this? L. What is this? K. What is this? J. What is this? I. A, B, C, D, E, F, GH, IJKL. Agreed? Let's connect them. This board will slip. If you become very careful, it will slip more. Then E, I, J, K, IL, KL, HL, JF, KG, I hope it is clear. A, B, C, D, E, F, G, H, I, J, K, L. What you see is the combined solid or a square prism which finally tapers to frustum of a square pyramid. Base is 40, height of the prism part is 50, then height of the tapering part is 20 and the top square is 20 mm square. It is a reasonable question. I don't say it is very easy, take some time because these points have to be very carefully drawn. You can try this using visual ray method or using two vanishing points. I don't advise using two vanishing points, but however you can try that. This seems to be slightly simple when you drop these intercepts. 1, 2, 3, 4, 5, 6, 7 intercepts you have to draw. You have to take only one vanishing point. Visual ray method sometimes may confuse, that is why I didn't prefer that. You can try that method, but it is a good question. You can expect such questions for the examination also. I hope you understand. I have marked all the dimensions. In the plan as well as in the position of HL, GL and these points also. When you extend this side, since it is cutting picture plane, it will represent true height. This is a line, these lines are called the line of heights, no? These lines are called lines of heights. When you extend a part of the object and cut it on picture plane, it will represent true height. You know that, true height. Since AE is on picture plane, AE already is 50. AE is 50. No other side will be true length. No other height will be true length. No side will be true length because there is no other part on picture plane. Anything on picture plane will have true length. What is picture plane? AE is on picture plane. So the height AE is 50. Nothing else will be 50. Height AE is 50. I have marked H and E at the same level. 50. Nothing else will represent true length. I, J, K, L. A, B, C, D, E, F, G, H, I, J, K, L. All are on their respective intercepts. Okay, I hope you understand. If you are now, I am trying the same problem using visual drawing method. I am not repeating the initial drawing, picture plane, plan of the object, station point, HL, GL, SP dash, then draw projectors down and draw the elevation of the prism, elevation of the solid. A dash, B dash, C dash, D dash. How are they drawn? Dropping projectors. Direct. A dash, B dash, C dash, D dash, E dash, F dash, G dash, H dash, I dash, J dash, K dash, L dash. That's elevation. Even the invisible edge I have marked as dotted. Join 4 plus 4 plus 4, 12 points to SP dash. All the bottom points, middle points and top points. 4 plus 4 plus 4. All the 12 points. 4 plus 4 plus 4. 12 points are joined to SP dash. Red lines. You can see red lines. Then intercepts. Where are intercepts? Intercepts are these blue lines. 1, 2, 3, 4, 5, 6, 7. Only 7 because AE is on PP. AE doesn't have an intercept. 1, 2, 3, 4, 5, 6, 7. All the intercepts which we have used in the previous problem, I have drawn up to this. Now you have to drop them. Drop them to the respective lines connecting the elevation points to SP dash. These intercepts are drawn or dropped to the lines connecting the elevation points to SP dash. Respective lines. Okay, let us check. I have stopped them in between. Let us check. B, intercept of B. This will be B. This will be F. BF. Okay. Then AE, no doubt. This is A. This is E. AE, no doubt. Okay. Then D. Before that we will finish the other point. A, B, C. We will finish C. C. D. A, B, C, D, E, F, G. G dash, SP dash, G, H, H. A, B, C, D, E, F, G, H. The top is completed. The top A, B, C, D base, E, F, G, H top. Then the other small square. Let us find them. I. 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 J. J. This is I. I. J. K. 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 This is K. L. Where is L here? I, J, K, L. This is L. Where is the intercept of L? Intercept of L is here. L. something wrong. I, J, K, L. Okay, let's connect them. Before connecting, we have to examine if it is correct. I, J, K, L. Those are the points. So I on the intercept I. This is I, no doubt. J. Where is the intercept of J? This is the intercept of J. J is correct. I, J, K, L. Okay. Something slightly wrong. Okay, let's connect. AD, AB, CD dotted, BC dotted, BF is firm, AE is firm, BH is firm, EF is firm, EH is firm, then E to be connected to I, EI, HL, FJ, IJ, LI, LK, KJ, and G. A, B, C, D, E, F, G, H, I, J, K, L. We have got it well. A, B, C, D. This is actually dotted. GC. A, B, C, D, E, F, G, H. Exactly above C is G, correct? E, F, G, H, I, J, K, L. So visual drawing method is not very difficult. The only thing is when you draw the elevation has to be very, very light. The elevation which is black, the perspective is blue, the elevation has to be very, very light. Otherwise it will completely mix up. I think visual drawing method is more or rather less time consuming. Agreed? So we have drawn it using both vanishing point method as well as visual drawing method. In vanishing point method, we have taken only one vanishing point. If you take two vanishing points, you can also try that. But I think now I feel this is a little bit better than single vanishing point. Okay. Thank you. I am showing it for the academic purpose for you to compare them. Now, if you are happy with the presentation, please subscribe my channel and share it among your friends and promote this venture. Okay. Thank you.